With the development of industrialization and urbanization, the abundance of heavy metals in the environment has increased enormously during the past decades, which raised significant concerns throughout the world. Heavy metals are a group of metallic chemical elements that have relatively high densities, atomic weights, and atomic numbers. The common heavy metals include cadmium, mercury, lead, arsenic, zinc, copper, nickel, and chromium. These heavy metals originate from either natural or anthropogenic sources, such as produced water generated in oil and gas industries, use of phosphate fertilizers in agriculture, sewage sludge, metal mining and smelting, pesticide application, electroplating, and fossil fuel burning. Heavy metals are non-degradable by any biological or physical process and are persistent in the soil for a long period, which pose a long-term threat for the environment. According to their role in biological systems, heavy metals can be grouped as essential and non-essential. Essential heavy metals such as copper, iron, manganese, nickel, and zinc are required for physiological and biochemical processes during the plant life cycle. However, they may become toxic when present in excess. Non-essential heavy metals like lead, cadmium, arsenic, and mercury are highly toxic with no known function in plants and may cause environmental pollution and severely affect a variety of physiological and biochemical processes in crop plants and reduce agricultural productivity. They can enter into the food chain through crops and accumulate in the human body through biomagnification, thus posing a great threat to human health. Phytoremediation is a plant-based approach which involves the use of plants to extract and remove elemental pollutants or lower their bioavailability in soil. Plants have the abilities to absorb ionic compounds in the soil, even at low concentrations, through their root system. Plants extend their root system into the soil matrix and establish rhizosphere ecosystem to accumulate heavy metals and modulate their bioavailability, thereby reclaiming the polluted soil and stabilizing soil fertility. There are several options of phytoremediation to choose from. These are rhizofiltration, phytodegradation, rhizosphere biodegradation, phytoextraction, phytostabilization, and phytovolatilization. There are advantages of using phytoremediation. First, it is economically feasible. Phytoremediation is an autotrophic system powered by solar energy, therefore simple to manage, and the cost of installation and maintenance is low. Second, it is environment and eco-friendly. It can reduce exposure of the pollutants to the environment and ecosystem. Third is its applicability. It can be applied over a large-scale field and can easily be disposed. Fourth, it prevents erosion and metal leaching through stabilizing heavy metals, reducing the risk of spreading of contaminants. Fifth, and certainly not the least, it can also improve soil fertility by releasing various organic matters to the soil. Phytoremediation is one of the most potent and viable solutions for poor farmers through community-based management. And because this technique is biological, the future belongs to it. The research on phytoremediation requires a proper understanding of processes and mechanisms which foster phytoremediation, the tolerance of plant species for saline and sodic soils, and market of agricultural products, which are produced as a result of phytoremediation. Further research and knowledge is required to commercialize this technique on a large scale and will ensure the food security in a sustainable way and will make the planet Earth more beautiful place to live.